Hi, my name is Dale Maley. I'd like to tell you about a very interesting project I recently finished, and it involves making Archimedes style wood screws. Now, a little background on this project. I've designed and built many different hand crank marble machines. You can see them in my other YouTube videos. And I probably have used about 5 different ways to raise the marbles up about 16 inches above the base. And then I release them, and they take their ways down in various different paths and chutes and things. Anyway, one method of lifting the marbles that I've not yet used is what is an Archimedes type screw for 1-inch marbles that I use. So in case you're wondering, what is an Archimedes type screw? Here's a picture of one. When I was a kid growing up on the farm in central Illinois, we used these for grain augers to move soybeans and corn. So the natural next question that arises is, how in the world do you make a long wooden screw? Well, in the past I have made wooden worm gears, which are essentially the same as the Archimedes screw. And you can see one in the picture in the bottom area down there below the mating spur gear. But they're very time consuming to make, in this case just a 4-inch long worm gear. Pretty much you remove all the material between the teeth with a Dremel. And I need a piece about 18 inches long to raise 1-inch marbles about 16 inches at an angle above the base. If you're interested in how to make wooden worm gears, I have other YouTube videos which explain how to make them and how to draw them in SketchUp. Now, I did search the internet for ideas, and really the only thing I found was where a guy made kind of an Archimedes type screw, and he used a whole bunch of rounded segments that he glued up, and then he had to do a lot of sanding as shown in the picture. So then I got the idea, why not make a fixture for my router where the router bit travel is synchronized with the rotation of the wood screw being made. And it'd be similar to how they cut threads on a metal cutting lathe. Big thing will be figuring out the gearing that I need to synchronize the two. Now here's a concept drawing showing how they make threads on a metal lathe. And down at the bottom you can see a lead screw. And in my case I'm going to use a 1-inch all-thread rod. Then going to the left you go through a gear set to get the right gear reduction ratio. Then at the top you got the piece you're going to cut the threads into. And let's see what else. Down the bottom it shows a carriage riding on the lead screw, and I'll have a similar thing, but the carriage will be carrying my router. So some key input factors for my design. I'm going to use 1-inch size all-threaded rod, which has 8 teeth per inch. I'm going to buy a 24-inch long piece of that 1-inch all-thread from a master car, and I'll to make an 18-inch long wood threaded piece. I will use 2-inch dowel to make the screw from, and actually that's the biggest size I can buy from Menards, and it's about the right size to hold 1-inch marbles. Now I need to buy a router bit for this project. I'm using 1-inch diameter marbles, so you might say, well, just buy a 1-inch diameter, it's called a core box bit. But 1-inch marbles are just a little bit bigger than 1 inch sometimes, so I'm going to go with 1 1/8, which will give me a little bit of clearance for the marble to fit in the groove. I'm also planning on leaving a 1/4 inch wide spot on the top of each of the wood teeth. So here's a side view of what the teeth will look like with the red 1-inch marbles. I'm leaving that 1/4 inch at the top of each tooth. I'm going to have a thread pitch around 1 3/8, and I'll be using an 1 1/8 diameter router bit. Now I have to figure out what gear ratio do I need to synchronize the speed of the router carriage and the piece that's being machined. Well, I'm using 1 inch by 8 teeth per inch all-threaded rod. I want a wood thread pitch around 1 3/8, which means the teeth per inch of the wood thread works out to be 0.72727. So if I take the ratio of those two, what I end up needing is a gear ratio around 11 to 1. Now that I know I need around 11:1 gear ratio, how in the heck do I achieve that? So I know of at least two ways of achieving 11:1 gear ratio. I could actually make a set of wooden worm gears. However, you have to transfer the gear train around by 90 degrees to do that, which wouldn't be easy in this case. Or I could use a set of 4 spur gears, which I have built before. Here's a sketch of the spur gear set I built on an earlier project, and you hand crank it on the right. The power goes into the bottom right hand green gear, which goes up to the purple gear above it. It's transferred over to the left to the smaller green gear, and then it's transferred down to the big purple gear on the bottom left, which is hooked to the output shaft going to the left. Now those lower two gears are not actually connected to each other in order to achieve this. So I made a little spreadsheet to figure out what size gears to use. What I ended up with on the 4 gears for their pitch diameters, I'd have a 3-inch, then a 10-inch, then a 3-inch, and a 10-inch. So if I do use a 3-inch, 10-inch, 3-inch, and 10-inch set of gears, what actual ratio do I get? And if you do the math, it comes out to 11.1111. Well, that means that my thread pitch is not going to be exactly what I thought, so I recalculated the thread pitch, and I come out with 1.39 inches, which is just a little bit bigger than the 1 3/8 or 1.375 I wanted. So that should work fine. Now, which shaft do I hand crank on? Do I hand crank on the 1-inch all-threaded rod or on the 2-inch diameter dowel that I'm machining? So it turns out, if you're trying to speed up the output, the cranking torque on the input will be much higher. On the other hand, if you're trying to slow down from the input to the output, the cranking torque will be much lower. Now we have a gear ratio around 11:1, which means the 1-inch threaded rod is running about 11 times faster than the 2-inch dowel being machined. To minimize the cranking torque, you should choose to hand crank on the 1-inch threaded rod because you're slowing it down by a factor of 11:1. Now I accidentally verified this is true because I first put the crank on the 1-inch rod and it was really hard to turn. And when I checked it out some more, I ended up switching to the 1-inch threaded rod, which takes a low amount of torque to hand crank and works great. So here's a drawing in SketchUp, my free drafting program, showing the machine that I came up with. So on the bottom, or on the left hand side, you can see the hand crank, and that's actually connected to the gray 1-inch threaded rod. And that 1-inch threaded rod has 8 teeth per inch, and it's 18 inches long. Then I have 2 green boards up there. Those are the router carrier guides, where the router carrier slides on those. The router, then you can see it's going to move left and right as I crank it. Then there's a 1-inch square nut which I need to hold on the router carriage so the threaded rod pulls it back and forth. So I came up with a wood fixture that contains that 1-inch square nut. And on the right hand side, that's that set of those 4 spur gears, which give about an 11:1 gear reduction ratio. Now the 1-inch square nut is blue and it's inside this wood block. So I came up with 3 pieces of wood that contain that screw, and I bolt those down to the carriage for the router. Now I did end up adding a couple of sheet metal shims inside of it to try to remove all the play in it right to left. Now looking up underneath the fixture, you can see the router carriage up there sliding back and to the right and left. In red down there is my router bit. And then the 2-inch dowel to be machined is down below. And then I ended up gluing on some end adapters so I could reduce those down to 3/4 inch shafts to hold it in place. So I want to have roughly 5-inch long pieces of 3/4 inch dowel on each side of the 2-inch dowel being machined. And first I drilled 3/4 holes in each end of that 2-inch dowel, and I glued in the 5-inch long 3/4 dowels. However, I noticed I had excessive run out meaning that the small dowel is not really parallel to the large dowel. And when I measured that, it's called true indicator reading or total indicator reading, I was out of round by anywhere from a quarter to half an inch, which is unacceptable. So I put the 2-inch dowel to be machined. I put that in a 3/4 inch wide groove on my table saw so I could rotate it. Then I put a dial indicator on as shown, and I turned it, and I saw how much variation I had in the 3/4 inch dowel. That's where I got the TIR readings from. So I had to improve how I attached those two pieces of 3/4 dowels on each end. So what I came up with, I sawed a 1-inch long piece off a 2-inch dowel, same diameter as a piece to be machined. I kind of marked that in the center with either an awl, or I actually marked it in the lathe with using the tailstock. And then I started to drill it in the lathe and took it off and went to the drill press and finished it. And I glued those on both ends. Then one at a time, I glued the 3/4 inch dowels into the end of the piece to be machined. And I used a steel machinist square to try to make sure they were 90 degrees to the end face of the 2-inch dowel being machined. I got a picture of that in a second. Anyway, after I used the new method, I got that total indicator reading down to only 50 thousandths to 90 thousandths of an inch, which is good enough. Now I could take the 2-inch dowel and turn the ends down to 3/4, but that's quite a bit of work. Here's a photo of using the steel machinist square to make sure that piece of 3/4 inch dowel is perpendicular to the face of the 2-inch dowel being machined. And then I checked it at 90 degrees or in two different directions to try to make it as best lined up with the 2-inch dowel as I could. In this photo you can see the 1-inch wide piece of dowel. It's got RH on it for right hand that I glued onto the piece to be machined. Then on the right hand side you can see the piece of 3/4 inch dowel, which I used a machinist square to make sure I had it in there perfectly parallel to the piece being machined. So here's a photo of the blank ready to put in the machine and cut to thread. When I'm done, I can saw off those 1-inch pieces on each end if I want to. Now here's a picture of the machine that I came up with for making Archimedes style wood screws. I don't have the router sitting in there. Instead there's a coffee cup sitting there. I'm all ready to put the router in, but you get an idea how big the fixture is from the coffee cup for scale. Now initially I used wood couplings in two places. You can see that it has blue masking tape, and there's a piece of 1/8 inch brass rod connecting up them with the shafts. So until I hot meld them to keep the pins from falling out, I just temporarily put blue masking tape. We'll later remove that and use hot melt glue to keep the brass pins retained. So now we're ready to make our first pass with the router. I set the router depth about 1/4 inch deep, and I made a little video showing the machine in operation, which we'll see next. So here's what a photo of what the piece being machined looked like after I made that first pass. It's really beautiful with the nice spiral grooves cut into it. So because that first pass with the router went so smoothly, I was really excited, and I thought, boy, this is a fun project and easy to do. There'll be no problem to make 3 or 4 more passes to get the depth down to about 1/2 inch for my 1-inch marbles. That was too good to be true because I ran into trouble when I was making more passes. and the router actually kind of caught and kicked out some wood, chunks of wood, as you'll see in a minute. And I think part of that was I had excessive backlash in the drivetrain. I kind of designed too much clearance in that wooden square nut assembly that holds the square nut. So I went in and I added 2 sheet metal shims in there in that assembly that's capturing the nut, and I reduced about an 1/8 inch of play down to almost nothing. Then on the coupling between the piece being machined and the gear train, I had 15 to 20 degrees of play in there using a wood coupling with 2 brass pins. So I put a slit in there and used 2 hose clamps to tighten it up. Here's a photo where you can see the split coupling that I added 2 radiator clamps or hose clamps onto, and that worked. You don't really want that to slip because you could really tear up the piece because the router will hit the wrong part of the grooves. Here's a photo of one of the chipped out areas on the right hand side. So I did get the depth down to about 1/2 inch, which is what I wanted for the 1-inch marbles, and I decided to try to salvage the piece by using some plastic wood from Ace Hardware to replace the chipped out areas. That actually worked pretty good, and you can see from the photograph the Archimedes wood screws looking pretty good by the coffee cup. So using the same process as I talked about before, using the machinist square and everything, here's blank number 2 ready to go into the machine and give it a second try. So I made another trip back to Ace Hardware and I bought a short piece of hose, clear hose, that had a 3/4 inch ID, and I put the 2 hose clamps on that, and it really makes a nice firm connection, and there's no chance of slipping and no play either while you're machining the main piece. So how did I go on the second go around? Well, the first pass I only set the router about an 1/8 inch deep cut, and I'm using my right hand. I did keep some downward pressure on the router on the carriage so it really can't kick back or anything, and then I cranked with my left hand. Once I made it all the way to the left hand side, I stopped the router, and then I ran it back to home position using my electric drill. Now pass number 2, I only set it for 1/16 deep cut. Did that pass, retracted it, repeated that process about 5 or 6 more times. I was almost to the end, almost had my 1/2 inch depth, and I got some chip out at the beginning of the carriage travel. Here's that photo where I got the chip out. And I think what happened was that's right at that glue joint where I glued that 1-inch piece on the end, and I might have just hit a hard spot when I was routing, and it was kind of weak there and it broke that piece out. So I measured as best I could. I was at 7/16 to 1/2 inch deep, and I only wanted a half, so I decided sometimes you're best to stop while you're ahead. As you can see from the photo, piece number 2 is really gorgeous, except for that one little chipped out area we just looked at. So again, I was able to use a little plastic wood and fix that up, so it really looks perfect now. So what did I learn after making 2 of these pieces, or some secrets to success? Well, one thing, you got to make a good blank, and you want minimal run out between the 3/4 inch ends and the main 2-inch dowel being machined. And I accomplished that by using a 1-inch long cap, glued it on, drilled it very carefully, and then I glued in the dowel. I used a machinist square. And then you probably want a higher quality coupling, like a piece of that 3/4 inch ID hose that I used to connect up the gear train. That really worked nice and it won't slip. I also think you want to try to take out as much backlash as you can in the system, and I did part of that was better securing the 1-inch square nut so it had less travel. And probably another really important thing is you only want to cut or route in one direction. If you tried to go back, you would have the backlash in the gear train, which would get the router off track from its right position. So in my case, I cranked the router carriage so it traveled right to left. I stopped, turned off the router, ran it back with the electric drill to home position, and hand cranked it the last little bit to the home position. I think the right amount of stock removal is also critical on this. I think you want to take lighter passes. That first pass can probably be a 1/16 to an 1/8 deep, but I think all the following passes ought to be only 1/16 to really minimize the chipping effect. Now, in case you're wondering, how does one draw an Archimedes type wood screw in SketchUp? Well, I actually have another YouTube video, and it's about how to draw wooden worm gears, which essentially are the same thing as the Archimedes screw. So if you're interested, check out the other YouTube video. So my next question was, how steep an angle can I raise marbles up with? So I made a little temporary wood fixture to hold the Archimedes wood screw, as shown here in this drawing, and I ran some actual tests, and I found out that 52 degrees to the horizontal, which would be 38 degrees to the vertical, is about as steep as you can go. Now you might be able to put some covers on top to keep the marble from falling out due to gravity and possibly approach 90 degrees. So I made a short video of testing the angle to see how steep it will still raise marbles. Let's take a look at that video now. Well, now let's see the Archimedes wood screw in action with 1-inch marbles. I have it at a pretty steep angle here. Let's go ahead and watch the yellow marble. And it's making it up the track just fine. So some closing thoughts on this project. It was very challenging, but it was a fun project for me. I've always been intrigued about getting two rotating axes in sync like the metal lathe does on its threading attachment. So as usual in most of these style projects, it takes some creativity, some process development, and some persistence to figure out how to do it. So in summary, this video explains how to design and build a hand crank machine that will make Archimedes style wood screws. I hope you enjoyed the video and maybe give you some ideas for your projects. Please subscribe. Thank you.